A light is at the top of a pole 10 meters high. A ball is dropped from the same height from a point 6 meters away from the light. If the ball falls 5 t squared meters in t seconds, how fast is the shadow of the ball moving along the horizontal ground through the base of the pole 1 second after being dropped? So it's best to draw out a picture to see what's happening. So a light is at the top of a pole 10 meters high. So here's our pole. It's 10 meters in height, and the yellow circle at the top represents the light. And this is the ground, the horizontal ground. A ball is dropped from the same height from a point 6 meters away from the light. So this distance here represents 6 meters, as does this distance, it's just not drawn in. So 6 meters away from the light, a ball is dropped from the same height. So this is the same height as the light. This is the point 6 meters away, and the ball is dropped. So for example, if that is the ball right there, then the light is shining down on the ball and it's casting a shadow down onto the ground. So it says if the ball falls at 5 t squared meters in t seconds, so the ball is falling towards the ground at 5 t squared meters in t seconds, we want to know how fast is the shadow of the ball moving along the horizontal ground through the base of the pole 1 second after being dropped. So how fast is the shadow of the ball? So this would be the shadow of the ball. And how fast is that moving along the horizontal ground through the base of the pole 1 second after being dropped? So we would imagine that this is where the ball would be after 1 second. And this is the shadow that the light is projecting down onto the ground. And as that ball gets closer to the ground, the shadow is going to move along the horizontal ground. So what's given? Well, y is equal to 5t squared. So that is the ball falling. So the ball falls at 5t squared meters in t seconds. So y is equal to 5t squared. And what do we want? We want dx dt, the derivative of x with respect to t. So x being this distance, notice that we have formed a triangle, a right angle triangle. X being this distance with respect to t, so we're differentiating x with respect to t. So y is 5t squared, so y is the ball falling, and t seconds. And the shadow is moving along the ground, but it can only go as far as here, because the ball will eventually stop here. So the shadow is going from this point to here. So this would be x. So we want the derivative of x with respect to t, and t is for time, seconds. So if y is equal to 5t squared, then dy dt, the derivative of y with respect to t, will be 10t, because 2 times 5 is 10, and 2 take away 1 is 1, so we get 10t. We want dx dt, and dx dt is equal to dy dt multiplied by dx dy. We know dy dt, it's 10t. Now we need to figure out dx dy. So we know we have a right angle triangle and we have parallel lines. So the blue line, which is the height of the pole with the light at the top, and the pink line, which is the distance the ball falls. So this is where the ball is after 1 second, and this is where it hits the ground. So these two lines are parallel, and they're inside of this triangle, which means that we can use similar triangles. So we have a larger triangle and then a smaller triangle, but they are similar, which means their angles are the same, but their lengths are different, but that their lengths are in proportion with each other. So similar triangles we know are similar, but they're not the exact same. So their angles are the same, but their lengths are different, but their lengths are in proportion with each other. So we're going to set up an equation in terms of x and y using the corresponding sides of our triangles. So let's take the smaller triangle. So we can take the horizontal side, which is the ground, which in this case is actually x, but we're just focusing in on the yellow part. So x, so that's going to be our numerator. That's going to be over or divided by the corresponding side of the bigger triangle, which is this side of the triangle, which we can call x plus 6 or 6 plus x. Then we take the smaller triangle's parallel side. So this is the distance that the ball moves. So this is where the ball is after 1 second. And this is where it hits the ground. And since all of this is 10 and this is y, this must be 10 minus y. So that's our numerator. And then that's going to be divided by the corresponding side, which is the other parallel side, which happens to also be the pole, which is 10. Now if these were upside down, so if you had x plus 6 over x equals 10 over 10 minus y, it works out the same. So long as you have, for example, the smaller triangle's measurements as both numerators and the larger triangle's measurements as both denominators, or vice versa. You can't mix them up. So now we have an equation in terms of x and y, and we will cross multiply. So we end up with x times 10 is 10x, x plus 6 times 10 minus y is x plus 6 times 10 minus y. Multiplying out the brackets, we get 10x minus xy plus 60 minus 6y. So we can cancel out the 10x's on both sides. We can bring the minus xy over the equal sign to become xy. Then we have 60 minus 6y. Divide across by y. So xy divided by y is x. 60 divided by y is 60 over y. Minus 6y divided by y is minus 6. So now we have the x on its own, and we can rewrite 60 over y as 60y to the power of minus 1, and we still have the minus 6. So if x is equal to 60y to the power of minus 1 minus 6, then dx dy, the derivative of x with respect to y, will be minus 60y to the power of minus 2. And we forget about the minus 6 because there's no y term attached. And this can be rewritten as minus 60 over y squared. Thus, dx dt is going to be dy dt multiplied by dx dy. We had that in the previous slide. Dy dt we know is 10t. So we have 10t in brackets. Dx dy we just worked out to be minus 60 over y squared in brackets. And multiplying, we get minus 600t over y squared. So when t is equal to 1, because we are interested in how fast the shadow of the ball moving along the horizontal ground through the base of the pole is after 1 second. 1 second of being dropped. So that's t equal to 1 second. So we swap that t for 1 with brackets. And y we know is equal to 5t squared. We stated that at the very, very start. If we swap that t for 1, so swap that t for 1 because we're interested after 1 second, we get 5 times 1 squared, which gives us 5. So y is equal to 5 when t is equal to 1. So we swap that y for 5, and therefore dx dt is minus 600 times 1 over 5 squared, which gives us minus 24. Thus, the shadow of the ball is moving along the ground at 24 meters per second. So here's the light. Here's the ball after 1 second. And the light is shining down onto the ball, and the ball produces a shadow on the ground The closer the ball gets to the ground, the closer the shadow moves along to where the ball will eventually land. So this shadow is moving along the ground at 24 meters per second.